Now we can represent a reciprocal function just as an extension of what we've done previously with the linear vectoring mode. So this is the CORDIC algorithm and the initialization and the output. So this is the CORDIC algorithm for our linear vectoring mode. Now if we were to look at the output that we get for this, then the angle term here would be given by z0 plus y0 upon x0. So this would be just our division algorithm. Now what we could do is we could set the value of z0 to 0, and then we could set the value of y0 to 1, and then the input will be your value of x0. So that means that the output Zn is equal to 1 upon x0, so that is the reciprocal of the value x0. So let's have a look at this in the graphical calculator. So this is the function 1 upon x that we've seen just in the previous page. Now of course, we're not necessarily going to represent this simple function 1 upon x. What we would like to do is to be able to represent the reciprocal of lots of different functions. For example, we could look at the reciprocal of the sine function, the cosine function, and the tan function, or the sinh, the cos, and the tanh. And those have their own mathematical names. Now we're not going to look at that here in this video, we're going to leave that for a later video, but that's the direction that we really want to take. So we would run through the CORDIC algorithm twice, once say for example to generate the sine function, and then you could run through this reciprocal and it will generate the reciprocal of the sine function. So let's look at just generating this function here for the moment. Now this is just the linear vectoring mode simulation, the same as we've seen whenever we worked out our division algorithm. Now let's say for example we want to find the reciprocal of the number 2. So in order to get that, the number 2, the reciprocal is 1 upon 2, the answer should be 0.5. So what we can do is we can put down the value for our x0, and we'll make our x0 the value 2, and we'll make the y0 the value of 1. So we'll have this vector here, and what we want to do is we want to decrease the value yi until it goes to the value of 0. So I'll go ahead and I'll add and subtract off the requisite angles. So you can see here that our final value for our y has tended towards 0. Now again, as we work through each of these iterations, we've got to add on and subtract off the angle to get Zn. Now I've already worked through this example here, and this is the final angle you get here. So this is the vector and this is the angle for Zn. And we get that angle by adding and subtracting these values here. And of course we add on and subtract off dependent on whether the value for our yi is greater than or less than 0, as we've done in previous examples. So the final angle here that we're interested in is this 28.423345 degrees. Now if we convert that to radians, we're going to have to multiply by pi and divide by 180. The final answer it's going to give is 0.4961. So the answer that we would be expecting to get would be the reciprocal of 2, which is 1 upon 2, which is 0.5. So we're not far off. The answer here is 0.5, and the answer we get is 0.4961. 1. So this shows us how we can generate the reciprocal function. But as I said, the usefulness of this is that we can generate a function using the CORDIC algorithm, so for example a sine or cosine, and then we can work out the reciprocal of that function by then running through this process here of finding the reciprocal. So that's all for this video. Thank you for listening. I'll get you in the next video. Goodbye.